Two objects are at rest on a frictionless surface. Object 1 has a greater mass than object 2. So rest 1 is of greater mass than object 2. Those are the key things. When a force is applied to object 1, it accelerates for a time interval of delta t. Okay. The force is removed from object 1 and is applied to object 2. Okay. After object 2 has accelerated for the same time interval, which statements are true? So we are looking at, let me put it on a picture, then let me put it as a diagram. So we have two objects. One is a heavier object. We are applying a force F. Initially, this is at rest. And the time, the duration for which this is applied. When the force is applied to object, it accelerates. And the time interval is dt. It has the acceleration of the same object 2 has accelerated for the same time interval. Okay. T is same for both basically. So we have the second object, the same force, same initial velocity. And here we have, say, m1. And this is m2. And this is delta t. Okay, I think anything else? We can call this as 1 and this as 2. Yeah, force is same and everything else is same. Now we're looking at the working. So again, we are trying to figure out the momentum aspect. So let's look into impulse, which is change in momentum, which is also F into delta t. So we can go back to, actually, we know that force is rate of change of momentum. But anyways, I'm just writing it. So change in momentum is equal to force into delta into t. So let's go case by case. Case object 1, it has a initial velocity of 0 as u is 0. Oh, sorry, this is object 1. And therefore, the final velocity of object 2 is force times of delta dt. Okay. Then we're looking at case object 2. Here too, the initial momentum is 0 as u2 is 0. Therefore, we have Pf of 2. This is F1, by the way, guys. F1, this is F2, which is F into dt. So what can we tell? So from 1 and 2, what can we tell? See, F is constant, dt is constant. Right? Both are applied, the force is applied for the same time interval. Of course, the displacement over here is shorter and here it will be larger. So that difference I have shown. If not, the quantities are the same. So from 1 and 2, what can we tell? Pf1 is equal to Pf2. And so your answer is equals to. Okay. So whenever you get any complicated situation, just keep writing the formulas. Keep substituting it. Even I didn't know the answer, honestly. All I did was kept my funda, the main thing clear. I used numbers when needed. If the force were different, I would have called this as F1 and F2. If the times were different, I would have called this as T1 and T2. The displacement will be different. That common sense I used. And then I wrote the obvious things. And the answer came up. I didn't do anything, honestly. I didn't overthink, nothing. Here I was smart about what I'm representing. I always like to put the diagram exact. You know, if someone asks me bowling ball, generally I tend not to go overboard and write a proper bowling ball, or circle is also okay. If someone tells a car, then I generally put a box. That's the only leniency I show. If not, my diagrams are always to the point. It should make sense to me. Only then all of this works. That should be the attitude. Right? Yeah. That's how you can approach such complex questions.